You know, we're living through this absolutely incredible moment. Artificial intelligence, it promises to revolutionize pretty much everything, right? From medicine to science. But there's a catch. Behind that sleek digital curtain, this whole revolution is powered by a massive, and I mean massive, physical infrastructure. And that infrastructure comes with a price, a physical one that we're really only just starting to understand. So today, we're gonna break down that cost. And really, this is the core tension here. On one side, you have AI, this leap in innovation that's just unlike anything we've ever seen. But on the other side, you have its physical footprint, which is enormous. It's putting this immense pressure on our planet's most critical resources. It's a classic double-edged sword, and we've got to understand both sides of that blade. So, let's dive right into the problem. To really get what's at stake here, you have to appreciate the sheer scale of AI's consumption. And believe me, the numbers are just staggering. Okay, so this chart really gets to the heart of the energy problem. A standard data rack, the kind that powers most of the cloud we use every day, that pulls about 5 to 10 kilowatts. Now look at an AI rack. It's packed with specialized GPUs, and suddenly you're jumping to between 30 and 100 kilowatts. On the high end, that is a tenfold increase. We're talking about a whole different league of power demand here. Now let's zoom out and look at the global picture. Right now, all the data centers in the world consume about 1 to 2% of global electricity. But with this AI boom, the projections show that figure could double to 4% or even more by 2030. And in hotspots, places like Ireland or Northern Virginia, data centers are already eating up over 20% of the grid's power. That is a growth curve that is practically vertical. To really get our heads around this, it's helpful to break it down into what the source material calls AI's three hungers. First, you've got the raw energy for all that computation. Second, the incredible amounts of water needed just to cool it all down. And third, all the critical minerals you need to actually build the hardware. Every single one of these is a major potential bottleneck. And each of these hungers creates its own geopolitical flashpoint. For energy, it becomes a race to control regions with tons of renewable power, like hydropower or solar. For water, it puts unbelievable pressure on areas that are already water-stressed. And for minerals, well, that just ramps up the global competition for supply chains, things like copper, lithium, and of course, the rare earth minerals that are dominated by China. And this is the crucial point, the one we're hitting right now. The first wall isn't a global lack of energy. It's that our electrical grids physically can't move it fast enough. In places like Northern Virginia, which is basically the data center capital of the world, utility companies are openly warning that they cannot build high-voltage power lines fast enough to keep up with demand. The pipes are completely full. So a crisis like this obviously forces a response. And what we're seeing now is a high-stakes technological race, a desperate scramble by the industry to innovate its way out of this resource crunch before it literally grinds progress to a halt. This is it. This is the single biggest question facing big tech right this second. How in the world do you power this revolution when the public grid, the very thing you've always depended on, just can't keep up anymore? Well, the answer they're turning to is to build their own. And the big answer they're betting on is a technology called small modular reactors, or SMRs. These are basically a whole new class of smaller, dedicated nuclear reactors. They're designed to provide a constant, carbon-free 24/7 power source directly to a data center campus. Now think about what that means. This is a huge strategic shift. Instead of just competing for public power, tech giants are on a path to becoming their own private, nuclear-powered utility companies. Okay, so maybe you can solve the energy problem. That's one part of the puzzle. But what about that second hunger? What about the absolutely insane amount of water these massive computer clusters drink just to keep from overheating? This number right here, this is the key. By switching from old-school evaporative cooling, which pretty much works like sweating, to these advanced closed-loop liquid cooling systems, you can slash water consumption by up to 95%. These new systems just recycle a small amount of coolant through pipes that directly touch the hot chips. It is a game-changing efficiency gain, and it means you're not drawing billions of gallons of water from local communities. So, to put it all together, the industry's response is basically a two-pronged strategy. First, go private on power. Secure your own dedicated energy by investing in new tech like SMRs to get off the public grid. And second, slash your water use by deploying advanced liquid cooling. It's a full-on engineering blitz to solve a massive resource crisis.
But these technical solutions don't happen in a vacuum. They have consequences that ripple out across the entire globe. So for our final section, let's look at how this new reality is creating a much more competitive and much more fragile world.
This quote from the source material, it just hits the nail on the head. AI isn't inventing new reasons for countries to compete over resources. It's just taking all the old tensions over energy, over water, over minerals, and it's pouring gasoline on the fire. It's an accelerant. To put this into historical perspective, think about it like this. The 20th century was really defined by the global race for oil. Then, the early 21st century was all about the race for semiconductors. Well, the era we are entering right now is going to be defined by the race for data, and just as importantly, the physical compute infrastructure needed to actually process it all. And the scary part is, all of this is happening at the same time. You've got AI massively accelerating energy demand, just as climate change is threatening our water supplies. On top of that, you have fragile mineral supply chains and this new great power race for tech dominance. It's a perfect storm. These forces are all compounding each other. And that really brings us to the final critical question. Maybe we've been looking at this all wrong. Maybe the real danger isn't some science fiction war for an AI. Maybe the real immediate danger is a world made more fragile, more competitive, and more brittle by the incredible physical demands of the AI revolution itself. And that's a reality we all need to start preparing for.